So that's all interesting. How do these then link up to all of these various uses of energy that we have up here? Well, it probably doesn't surprise you to learn that electricity is extremely versatile. So electricity is used for many of these. So one of the ones it's used for is heat. So we might use it, say, in reverse cycle air conditionings in our homes. We might use it in electric resistance heaters for toasting our bread in our toaster, or for microwave ovens, things of that nature. You might have electric ovens. There's plenty of uses for electricity direct as heat. We also use it for cooling. It's a very common use for cooling, so for running refrigerators and air conditioners. So electricity is used for that as well. As you probably would expect, the very first use for electricity on a mass scale in our society was for producing light, when the electric light bulb was invented. But we've since converted that using the old style incandescent lights. We've now got LEDs and so on. It's also used for mechanical work. So what mechanical work is generally things that move. And so mechanical work driven by electricity could be things like driving pumps or compressors in industry. It can also be, if you are one of the fortunate people driving an electric car, well, electric cars basically turn electricity, which is stored in the form of a battery in the car, directly into mechanical work using electric motors. Information processing is a very common use of electricity. In fact, in our society, we don't have mechanical calculators anymore, so electricity is a virtual monopoly on running our computing systems these days. We do find in some instances electricity is also used for metal smelting, particularly in things like electric arc furnaces and in metals recycling. So they'll use very, very high voltage, high current devices and use electricity to drive that as well. The only one that it's not really used in any significant amount is for making chemical feedstocks. So chemical feedstocks, generally we can't make those from electricity. We stick with them as... But what you can see there immediately is that electricity is covering a huge number of different requirements for energy in our society. It's really versatile. All right, let's have a look at some of the others now. You'll notice here that diesel, ethanol, petrol and jet fuel, you're probably familiar with those mostly in the forms of running engines. And so that's immediately a case where we can see here mechanical work is generally provided in our economy by burning things like diesel. Usually we wouldn't be burning ethanol on its own. Usually it's a mix with petrol, as I said before. But if I draw these arrows here, you get the idea. We've got our petrol and my diagram is starting to get more complex here. And so essentially what these lines are representing is the use of petroleum products, in particular those from oil refineries, to run vehicles of various kinds. So trucks, cars, buses, aircraft, ships, you name it. Also some mechanical work is provided through diesel-fueled industrial equipment as well, but that's a more minor use. And finally, we've got here natural gas. Natural gas is used often for providing heat. So we burn natural gas very commonly to provide heat in homes and buildings. So we have to bring that line all the way across. So natural gas is very commonly used in that regard. It is possible to use natural gas for cooling, but that's a very minor and very uncommon use, so I won't put that down. Similarly, natural gas could be used in gas lights, but again, we don't use gas lights very much anymore, so I'll leave that one off. Natural gas is also used to produce mechanical work, particularly in gas-fired equipment in industry. So you'll have some equipment will actually have gas turbines, for example, which can be used to generate mechanical work. Information processing, no, not really. Metal smelting or reduction. Occasionally you might find natural gas is starting to be used in a few places, but it's not a major use for natural gas. But another interesting one, and this is an area where chemical feedstocks can actually be made, depending on the chemical feedstock, can be made directly from natural gas. So that's maybe if you're making ammonia, for example. And also byproducts of natural gas. So these might be things like ethane and propane and other chemicals that we get along with natural gas. They can also be used to make chemical feedstocks. So see, it's gone around that natural gas box. They're piped separately. And similarly, we can make chemical feedstocks from various byproducts of oil refining. So in fact, sometimes they're the same chemicals. There's actually some overlap here between what oil refineries can make and what natural gas plants can make. They're not completely discrete. So there's your overview. There's a bit of an overview of at a very simple level, how some of these flows of energy work between our energy sources and our final uses of energy at the top here. However, one thing that you might be interested to know is that there are a few streams that add some complexity here. So for example, one of the products that we get from natural gas plants is something known as condensate. So condensate is basically a very light crude oil that is removed from natural gas. And what we can do is send that to an oil refinery. So I'll call this here condensate. So condensate is a light crude oil. Effectively, it tops up the crude oil that's coming from just in its standard form from the ground. But the main thing that you see here, and the main thing that I wanted you to get from looking at this broad overview and stepping you through this somewhat laboriously, is that the flows are all very linear. You notice that there's a general flow in one direction. They all flow from the bottom to the top, with the occasional little kink like the condensate line here. And you say, well, so what? What's so interesting about that? Well, in my next presentation, I would like to talk you through where I believe there's some real opportunity to shake things up here and really give really free up our energy markets to do a lot more.